plugged in. It's wireless. So we can make that much better. I probably have to is that going to stay up? I stop join.me and come back in so that I'm on the wireless, because right now it's still trying to do. I was authenticated wireless, but as soon as I plugged in the wire, I need to redo it. Let's see if this. Is that the same number now? Or is that a different number?
That's the same.
Is that the same number?
Yeah.
You remember the card you were like, I was about to be highly disturbed. I mean, yesterday I had guns.
Okay, so the question is, where do we pull off this from? Well, again, 1 minus u is the linear, and so here are the coefficients of that. But we have a 3u squared out in front of that, so we have to take this coefficient, which is the expansion of a third degree polynomial, take this and multiply it times that with a u squared, and that will give us this term, okay? And then it's just 1 . So this MBE matrix, whenever you see it, it's going to have the expansion of the coefficients of, let's go back a little bit, right there. So what's the coefficient on this term? Is 1. What's the coefficient on this? Is 3. The coefficient on that is 3. 1. Those coefficients get written down the diagonal, down the first column, and across the bottom row. These other terms come from looking at the expansion of 1 minus u squared, the quadratic Pascal's triangle. This comes from the linear row of the Pascal's triangle, times those coefficients. So there's a 3 that has to be multiplied times that to get this other column, the 3, the minus 6, the 3. This coefficient comes from the 3 being multiplied times the expansion of the linear coefficients, and you get 3 minus 3. Does that make sense? Okay. So let's kind of look at the quadratic for a second, which we did last time. So the first thing that we do is we take the Bezier summation form and we write the terms. So the first term is 0.0 times 1 minus u squared. Second one is 2 times the second point, u, 1 minus u. and 0.2 times u squared. Okay. And again, you kind of pull this all out, and you get the MBE for a quadratic curve being 1, minus 2, 1, 0, 2, minus 2, 0, 0, 1. Okay. And we did the linear, and so we kind of wrote that out. Okay. What happens if you want the tangent vector? You want the tangent vector to any place on the Bezier curve. How would you go about getting that tangent vector? Okay. Well, you take the derivative with respect to the only thing that's not a number, which is your u vector. So you can come in to your u vector, the derivative of 1 with respect to u, 0, derivative of u to the first, 1, derivative of u squared, 2u, and 3u squared. This multiplied times numbers, okay, will give you the equation of any tangent vector along the curve. So in the CAD systems, when you say, where is the tangent at this point, it can just put a vector in very quick because it has this in memory and can just run it. Question?
Yeah, so the MBE matrix is going to be the same both for the, when you're finding the equation of the line and for the tangent curve?
Exactly. It doesn't change because it's just numbers. What about curvature? If we want curvature along the curve, what's going to change? Well, this will become the second derivative, right? And this is all numbers. And so we can very quickly ask questions about curvature on a curve or calculate the curvature on a curve just by taking the second derivative with respect to it. So there's a note about Pascal's triangle. And you should be able to literally just write down what the MBE is for any order of a curve. You should be able to just write it down. You should be able to talk about the points along the way. And so here's our example. So if we were doing a fourth order Bezier curve, we'd write down the matrix or the Pascal triangle. We take this because it's a fourth order. We go to the fourth and we write down in the first column those numbers, alternating signs. We write it down the diagonal, all positive. We write it down the bottom row, alternating signs. How do we get the rest of the numbers? How do we get the minus 12, 12? How do we get the minus 12 there? Where do those come from? Well, if you think about what column this is, you know it's always going to be whatever the coefficient is. So there's the coefficient. There's the coefficient. So wherever the coefficient is, which is 4, okay, it's the coefficient of this term, 4, times the expansion of whatever the 1 minus u is. So we go to Pascal's triangle, and the 1 minus u cubed is the cubic set. And so it's going to be 4 times 1 put here. Why is it in the second row, second column position? Why is it there and not at the top? Because we have a u times this thing. We don't have any just constant out of this blending function. There is no constant value there. So it's the 4 is put in the place of the u term. The next one is 4 times the 3, 12, alternating signs, minus 12. 4 times the next term, 3. Okay, positive. And the last one, 4 times 1, which is the minus 4. How do we get the third row? Well, it's this coefficient times the expansion of the 1 minus u squared. 1 minus u squared is the 1, 2, 1 row. 6 times 1 is 6. Why are we putting it in the third row, third column? It's because we don't have a constant term. We don't have a u to the first. We have u squared. Okay, so that's why it goes there. We take 6 times 2, minus 12. We put it there. We go 6 times 1, put it there. Does that help you kind of understand how to write? So we're going to do an exercise. I think I challenged you last time to do 7th order. Is that right? Didn't we say 7th order? So if you don't have that written down, we're going to do 2 minutes and do a 7th order. Not that you would ever do that in real engineering, but if you do it now, you won't forget it. So try and do a 7th order MBE matrix. Marissa, can we shoot the camera at one of these boards and have them, the remote students, possibly see, or they're not going to see because it's joined on me, right? They would have to see something coming through my laptop, right? So we'll just tell them the numbers. Your 2 minutes are no. Keep working. Beginning to see it. Help to have light or not light. What if it's green?
It's better here than it does in here.
Is it?
Yeah, I think it's fine.
Hey, how many are done here in